Hello, my successful students. This is Pre-Algebra Lesson 2 with Mrs. Carla, and we're going to start out with some very important terminology that you should already be familiar with, okay? And that is addend, sum, right? When we're adding two numbers together, we call the two numbers that we're adding together the addends. 23 plus 42 are both add-ins that are going to add together or sum to give me 65. 65 is the sum, and summing is the process of adding two add-ins together, okay? Now, if I take that same problem and undo it with subtraction, I get 65 take away 42 is 23, don't I? Okay, so here the minuend is the number we are subtracting from. 42 is the subtrahend. It is the number that we are subtracting from another number, the minuend. And this is called the difference. 23 is the difference. So it is minuend minus subtrahend equals the difference. When we're multiplying, both numbers are called factors. Just like when we're adding, both numbers are called add-ins. So factor times factor is product. And 3 times 5 is 15. 3 and 5 are both factors, and 15 is the product. And then when we turn that equation around and make it a division equation, we take 15 divided by 15 is 3, and the dividend is 15, and the divisor is the number we are dividing by, and then 3 is the quotient or the answer to a division problem. Let me make sure you can see this. Okay, these are terms that you should be familiar with already. Now I'm going to come back in a moment with some things that maybe you're not so familiar with, but we have to learn. All right, so here we are back with some terms that may not be quite as familiar, but are very, very important. And that is the commutative property, okay? Commute means to move. If I were commuting to work, I would get in my car and I would go someplace else, okay? So commute means to move. And when I am using the commutative property of addition, the property is telling me that it does not matter whether I say A plus B or B plus A. The sum of the two will be the same, and the order does not matter. Okay, so the commutative property, if we were going to write some words that meant the same thing, it would be order does not matter. Okay, so that is the commutative property. Now we have a commutative property of addition. We also have a commutative property of multiplication. A times B is the same thing as B times A. Now, we have learned this before, but it's always helpful to draw some pictures, okay? So let's take 3 plus 2 is 2 plus 3. Okay, now if we were going to draw a picture of 3 plus 2, we would have 3 items plus 2 items, okay? And then if we were going to draw a picture of 2 plus 3, we would have 2 items plus 3 items added to it. Do we still have 5 on both sides? We do, don't we? All right, so 3 plus 2 and 2 plus 3 are both 5, and the order that we add them in does not matter. That is the commutative property of addition. Now, let's look at this one. What if we let A be 3? Okay, so remember, multiplication is a little different. If I have 3 times 2, now this little symbol here, this little dot, is to keep us from getting confused, all right? In the last part of your basic skills, you started to work a little bit with a little bit of algebra, unknown numbers. What do we often call an unknown number? X, all right? We often name unknown numbers X, Y, or Z, or something like that. So X can get a little confusing. The times sign could be mistaken for a multiplication sign. So to avoid that, instead of using the X in our algebras, for times, we use a little dot, okay? So when we do 3 times 2, remember 3 times 2 means 3 groups of 2, okay? So we're gonna draw a picture of 3 groups of 2. 1 group of 2, 2 groups of 2, 3 groups of 2, okay? So then over here, I'm going to switch these. So I'm going to have 2 times 3. Well, 2 times 3 is 2 groups of 3. Okay, so I have 2 groups, but in each group, I now have 3 in each group. Now, my pictures don't look the same on each side, but is the product the same? Okay, well, this is 3 groups of 2, so that's 2 plus 2 plus 2 is 6. Okay, and then on the other side, it's 2 groups of 3, which is 3 plus 3, which is 6. So it doesn't matter which order I multiply in, I still get the same product. And that is the commutative property of multiplication. Now, I wrote it for you this way. No, we'll do that with the associative property. Now, that's the commutative property. Now, we're going to talk about another property, and it is the associative property. Now, remember, what does the word associate or associate mean? Okay, if I said, I don't want you to associate with that person, you would say, okay, I can't be buddy-buddy with that person. Okay, so the associative property has to do with grouping, the buddy-buddy, okay? So here it's saying that I'm going to get the same sum if I add the A and the B, I group them together, and then I add the C later, or over here I'm grouping the B and the C together, and I'm adding the A. Okay, well, we can draw a picture of this. If we were going to let A and B be 1 and 2 and C is 3, okay? If we added 1 and 2, we would get 3, and then we'd take that 3 and add another 3, and we would get 6, right? Okay, then over here, remember A was 1, and B was 2, and C was 3. Well, here I've got B and C buddied up together. They're pals, they're associates. So 2 plus 3 is 5, and then I take that 5 and I add it to the 1 over here, and what do I get again? I get 6. Okay, so the associative property of addition is telling us that it doesn't matter which way we group, as long as we're always adding, we will get the same sum. They will be equal, okay? So associative has to do with who is grouped with who. So grouping is your associative property, okay? So now let's look at the associative property of multiplication, right? Well, we're going to put them in here again. We're going to say A was 1 and B was 2 and C was 3. And then over here, A is 1, and B is 2, and C is 3. Okay, now, remember, we're going to talk more and more about order of operations. But order of operations, we have to do what's in the parenthesis first. So, over here, we have A and B in the parenthesis together. And A times B is 1 times 2, which is 2. And then we take that 2 and multiply by 3, and we get 6. Looks like all the answers are going to be 6. We'll have to fix that, okay? And then over here, we have 2 times 3. The B and the C are grouped together. 2 times 3 is 6. But then we take that 6 and we multiply by 1, and we get 6. We still have 6. Okay, so that is the associative property of addition and multiplication. Now notice when I did my multiplication here, I included all of those dots. Here dot, there dot, here dot, there dot. Lots of dots. Sometimes those dots can get confusing. When we're dealing with variables, we can leave the dots out, which means we can put an A and a B right next to each other, and we know that if they're side by side, that is multiplication. Okay, we also know that if we have a parenthesis and something right outside it, that's multiplication also. Okay, so we could have written the same thing in this way without the dots. The last one, well, we're doing 2 more, and it's the identity property. Okay, now, when you go to bed at night, do you expect to wake up in the morning the same person? Well, I hope so. Okay, we don't want any Dr. Jekyll and Mr. Hyde going on here, right? So when we go to sleep at night, we expect to be the same person in the morning because I'm Mrs. Carla, okay? And I'm going to hope I'm still Mrs. Carla when I wake up tomorrow morning. That is my identity, okay? I am Mrs. Carla and I don't expect to change. Now, the identity property of addition is talking about a special number, which is the identity number of addition. What number can we add to any other number and not change the identity of the number that we added to? And the answer to that one is 0. That special number in addition is 0. We can add 0 to any number and not change its identity. Okay, so that is the identity property of addition. Let me move this down just a little bit so you can see the bottom of the board. There you go. Okay, so A plus 0 equals A, or 3 plus 0 equals 3. That is my identity property of addition. Now, that special number for multiplication is 1. Remember, we can multiply any number by 1 and not change the identity of the number. Okay, so that special number is 1, and A times 1 is A. A goes to bed, A wakes up, A is still A, and it doesn't have an identity crisis. That would be an identity crisis if you woke up and you were somebody else, right? Okay, so this is the identity property of addition and multiplication. And these are things you know are true already. You already know they're true, but we're putting names to them now. And the last little property here is the 0 property. Okay, this is the 0 property of multiplication. When we multiply by 0, we certainly get a change, don't we? Because any number times 0 is 0. Anytime we multiply by 0, we get 0. Okay, so this is the end of our lesson for lesson 2, but we're going to come back in just a minute with some examples for you to work through with me. All right, so here we have some practice problems for lesson 2 of pre-algebra, and we're going to try to name that property. Instead of name that tune, we're going to name that property. So we have 5 times 1 is 5. All right, what's our hint? 5 goes to bed, 5 wakes up, he's still 5. He hasn't changed his identity. All right, so this is the identity property of multiplication, excuse me, of multiplication. The identity property of multiplication. Now, I want you, whoa, whoa, whoa. All right, now I want you to do this one before I get there. 4 plus 8 equals 8 plus 4, which is the property where you could switch things around and they would be the same sum. Okay, so this is addition because we're adding them together. And that one was, which word means move? It is the commutative property of addition. Commutative property of addition. Okay, and this one has got some parentheses, which means we're grouping things together. And which one was the grouping property? Associative, right? Okay, so this is saying that 2 plus 3 grouped together and done first, and then adding 4 is the same as 2 plus 3 plus 4 being added first. Okay, so it doesn't matter whether 2 and 3 are buddies or whether 3 and 4 are buddies, the answer is the same. Notice that there is no movement. Okay, 2, 3, 4, 2, 3, 4. No changing in position, only a changing in who is grouped with who. So this is the associative property of addition because everything is added. Okay, the associative property of addition. 0 times 8 is 0. Well, there's a lot of zeros in there. That must be the zero property. Zero property. Okay, any number times 0 is 0. And it's the zero multiplication property. It's not the it doesn't work for addition because remember when we add 0, it's an identity property. Okay, so this is the zero multiplication property. Now we have a little mystery number down here. Let me get this down a little bit. Our little mystery problem says, what is the difference? I lost my H. What is the difference when the sum of 6 and 8 is subtracted from the product of 6 and 8? So let's look at these two things. The sum of 6 and 8. What would be the sum? Sum means to add together. So the sum of 6 and 8 is 6 plus 8 added together, which is 14. Okay, so we can take this sum of 6 and 8 and we can take that out and we can say 14 when 14 is. All right, so then we're going to subtract the 14, is subtracted from the product of 6 and 8. What is the product? That's when we multiply two things together, right? And those two items we multiply together are called factors. And so 6 times 8 is 48. So 6 times 8 is 48. So we're going to take this out and put 48 here. Okay, so now what do we have? What is the difference when 14 is subtracted from 48? So 48 goes first, doesn't it? And then we're going to subtract from it 14, and the difference is going to be 34. Did you get that mystery number right? Okay, I'm going to be back in a minute with some more problems to put on our board to practice lesson 2. All right, here's some more practice for you on lesson 2. And this first one says simplify 26, take away 48. All right, well, this is a good time to review what happens on the number line when we do subtraction. Okay, if we were going to do this problem, all right, so here's 0. Okay, I'm going to kind of go pretty quickly on this one. But let's suppose that we had way over here was 26, and it is 26 steps. So this number is represented by this point on the number line, isn't it? But then we're taking away a number that is bigger than 26, okay? And so it's going to be way over here. We're subtracting 48, okay? Which means we're going to subtract the 26 and then some more until we have subtracted 48 altogether. And we're going to wind up over here to the left of 0. Negative something. Now, how do we figure out what that negative number is? Okay, now let's talk about our two rules. We can do all of our signed addition and subtraction with just two rules. When we're adding, if it's the same sign we add, we keep the common sign. Okay, if it's opposite signs, we subtract and take the sign of the greater. Okay, so those are our two addition rules. If we're adding two same signs, we add the two numbers and take the common sign. If we're adding opposite signs, we subtract and take the sign of the greater. Okay, in this case, we have a minus 48, which is bigger than the 26. And our answer is going to take that negative sign, isn't it? Now, when we're subtracting, there's only one rule. Subtraction is addition of the opposite. So we can take this subtraction problem, 26 take away 48, and we can change it to addition of the opposite number. Okay, so instead of 26 minus 48, I'm going to say 26 plus a negative 48. Essentially, all I'm doing is attaching the negative number to the number behind, right? I'm connecting it to the second number, okay? So remember, that second number is called the subtrahend. Minuend, subtrahend, difference is the answer. So to find the difference, now that I've changed my subtraction into addition of the opposite or attached that minus sign, now I can use my addition rules, okay? Am I adding like signs or opposite signs? The 26 is positive, isn't it? But the 48 is negative, so I have opposite signs, therefore I will subtract the two absolute values, which are the numbers without the signs, right? So I'm going to subtract 48, take away 26 is 22, but then I'm going to take the sign of the greater valued number, greater absolute valued number, which is a 48, and the 48 is sporting this negative sign. So my answer is going to take the negative sign. Okay, now look what happened, all right? The 26 steps is how far we go back to get to the 0 here. And then we have 22 more steps that we need to take backwards so that we wind up at negative 22 for our answer. So that's just a little review of sign numbers, which I will do over and over again until you've got them just like that. All right, now we have a problem that says justify each step. Now that you're getting into pre-algebra and algebra, you're going to have to think of the reasons for your steps. And that's where our properties come in. So this was our given. In other words, they started here in the problem 4 times the quantity, 2 times 3, okay? So now we have to justify each step with our properties. What property tells me, now when we're justifying, we look at what is different. What has changed between the given problem and this new problem? Well, the 4 is the same. The times is the same. The order has changed. Since the order has changed, I'm going to say that is the commutative property. So I'm going to say commutative property multiplication because I am multiplying. Okay, so that is my justification or my reason why I can turn the 3 and the 2 around. Now, look at what's different between this step and the next step. 4, 3, 2, 4, 3, 2. They haven't changed the order. They've changed who is buddied with who. They've changed the grouping. Which one of our properties has to do with grouping numbers together? That is the associative property. Okay, so that is the associative property of, are we going to say addition or multiplication? We got those little dots everywhere, right? So that's the associative property of multiplication. So then, when we look here, all they've done is multiply 4 times 3 to get 12. Okay, so the reasoning behind that, let me lower this down just a little bit so I get the bottom of my screen. Okay, whoops, I better hold it. Okay, the reason here is that 4 times 3 is 12. 4 times 3 is 12. Okay, and then at the last step, they're just multiplying these together. 12 times 2 is 24. 12 times 2 is 24 is the reason why that works. Now, we're going to be back with even more practice problems in a moment. Here we are with the last little bit of lesson 2 of pre-algebra. Okay, how do you check a subtraction problem? Well, let's put a subtraction problem up here. 23 take away 17 is 6. All right, let's remember our really cool names for everything. Remember, this is your minuend, subtrahend, and difference. Okay, so if you wanted to use the cool names for how you would check it, you're going to say take the difference and add back the minuend to it. So if I take 6 and 17 and I add them together, I get 23. Okay, so now how do we check a division problem? What were those special names? If we said that 20 divided by 4 is 5, okay, we know that to check a division problem, we have to multiply the 5 times the 4 to get the 20. Oops, what did I do? I used my little X instead of my cool little dot. All right, so remember, what are our terms? When we are dividing, this one right here is the quotient. All right, and this one right here is the divisor. And this one right here is the dividend. So if we were going to use our cool words on how to check a division problem, we would say that we multiply the quotient by the divisor to get the dividend. All right, so now we have 2 problems down here, and we're going to do these 2 problems, but we're also going to talk about why we can do them. All right, so right here, anytime I'm trying to solve for a missing number, and you did this at the end of your basic skills section, anytime I'm trying to solve for a missing number, I'm trying to get that missing number all by itself. So over here I got this 12 sitting here bothering my missing number, so I want to get rid of that 12. Since it is joined to my missing number by addition, I'm going to undo that with subtraction. So I'm going to subtract 12, but I can't just subtract 12 from one side. I must also come over here and subtract 12 on the other side. And that's called the subtraction property of equality. Okay, when I have an equation, I have to subtract something from both sides, not just one side, because it's like a balance or a scale. And if I'm taking away 12 on one side, I'd better take away 12 on the other side. So now I get, this cancels, I get m equals 48, take away 12, or 36. Okay, so I have an answer. Now, how can I check that? Can I take the 36 back up here and check it? I should, shouldn't I? Okay, so 12 plus 36 does equal 48. Okay, now over here, we have another missing number problem. 12 times n. Now, I don't have to have that times there because I can tell that they're multiplied together. And if I had a 12 and a 3 here, I would have to have a times sign because I wouldn't be able to tell where my numbers started and ended. But because I have one of them as a variable, I can say 12n, and I know that 12n is the same thing as 12 times n. Okay, so now that my n is bothered by this 12 over here, trying to get rid of that 12, since it's joined by multiplication, I will undo that with division, right? So I'm going to divide by 12. Over here, I must also divide by 12. Again, whatever I do to one side of the equation, I must do that same thing to the other side of the equation. So now my 12 cancels my 12, and I'm left with n equals 48 divided by 12. 12 goes into 48 4 times. Okay, so n is 4. So to check that, I would go back. Let's go backwards to my original problem, okay? And 12 times 4 does equal 48. And this is Mrs. Carla, and we have done lesson 2 of pre-algebra. Now, what I'm going to do in our pre-algebra is I'm going to spend the time going through 5 lessons of concepts, and then we're going to have a workshop section where we're just going to work through problems to make sure those concepts are A-OK and you understand them. So we'll have a whole bunch of problems on the 6th lesson. So we'll do 5 concepts and then we'll have a problem set that's going to go over all of those lessons. So right now you're kind of getting off with just doing what I'm doing on the board. The time will come where you'll have some problems to work yourself, okay? So this is Mrs. Carla, and may God bless your day.